In section 2.6, we're looking at proofs. Now we're looking specifically at geometry proofs, and this section is just going to look at angles. We want to prove certain theorems about angles, so first we want to look at what a theorem is. A theorem is when we take one of our conjectures or statements and we prove that it's true. Now, when we do a proof, we can use any given information, definitions that have already been established, properties, postulates, and any theorems that we've already proven. We can use those as our reasons in our proof. So starting out is the vertical angle theorem. This should already be familiar. We've already noticed this pattern before. Basically, it's saying that the angles across from each other, here 1 and 3, are congruent. And we can also do the same with angles 2 and 4. And we're just going to look on this page at the first two. Now we want to think about this when we're going to prove it as a conditional statement. Vertical angles are congruent, so we could think of that as if two angles are vertical, then they are congruent. We want to then think about it as a hypothesis and then also as a conclusion. So remember, the hypothesis goes the if part, the conclusion is the then part. Now I want to look at that then because I can take whatever is my hypothesis is going to be the given statement in my proof. Whatever the conclusion is, that's what I'm trying to prove, must follow from that. Now I'm not going to use these words. I'm going to use the symbols and the picture that I'm given. And I'm going to rewrite that as angle 1 and angle 3 are vertical angles. So I'm specifically naming which angles I'm using in my proof. And then I'm going to prove that they are congruent to each other. When we set out to do our proof then, we're going to start with that as our heading. Okay, notice we're taking this directly and putting it as our heading. We must have this heading as part of our proof. And we must also have a picture. If in our proof we're referring to angles 1 and 3, we need to know how they're arranged. Because angle 1 and 3 don't have to be arranged in different ways. Here this is a vertical angle, so we should see where they're arranged. In some proofs, if they're not drawn, then we might come to a different conclusion with a different picture. So the picture is absolutely necessary for a proof. The next thing is when we begin our proof, we're going to make this into two columns. We put our statements on one side, reasons on the other. And usually, not always, but we're usually going to start with our given statement. And that's going to be our reason. Why do we know it? Simply because it's given. So you shouldn't miss, you should have all three of these things. Even if you don't know how to do the rest of it, you can at least write that down. Okay, now we're going to use deductive reasoning to figure out what happens next. And so we're going to look at this picture and see if we can figure out some more information about this. Now you might notice that they've drawn the number 2 on here also, because it's going to help us. We notice that 1 and 2 are a linear pair. We should also recognize that a linear pair is supplementary. So between 1 and 2, they're supplementary, and also 2 and 3 are a linear pair, and so we have two pairs of supplementary angles. Our next step then is to think about what does it mean to be supplementary. Well, when they're supplementary, that means the angles add up to 180 degrees. And so we've put our next reason here to explain why we're able to say that, but this reason is based on a previous step, just like this reason here is based on a previous step. Now, based on this step, we're going to notice something else. These are both 180 degrees, so I can move these around and just say the two parts are equal to each other. Basically, I'm substituting, rather than 180, I'm substituting this. This could also be considered the transitive property of equality because we're taking the entire side. Now the next step, notice we have 2 on both sides, so if we subtract it away, we're left with 1 and 3. That's the subtraction property of equality. Again, I've taken my previous step, I've done something to it, I explain why I did it, and then I write down what happened. Now finally, we haven't exactly gotten this. This is 1 and 3 congruent. We're dealing with addition and equals. We want to change it back to equals. Well, our definition of a congruent angles, when they have the same measure, they're congruent. You could also write this one as the definition of congruent angles. In this next proof, we're going to use the vertical angle theorem as one of our reasons for doing this. After we've already proven it, we're allowed now to use it in our proof. So we're starting here. Angle 1 is congruent to angle 4. We can start that as our given. We have a proof or a picture over here to go along with our proof. Now notice how this is arranged. We know that 1 and 3 are congruent, and we know that 2 and 4 are congruent because they're vertical angles. But we're asked to show that 1 is well, actually show that 2 is congruent to 3, we know that 1 is congruent to 4. Well, what we should notice then is that 4 is congruent to 2 because there's vertical angles there. And then we can connect that with angle 1 by using the transitive property 1 to 4, 4 to 2. We also know that 1 and 3 are vertical angles, so they're also congruent. And then in our final step, we use the transitive property again just to move that around and say, well, rather than 1 to 2, 1 to 3, we can also say 2 to 3. The book will also sometimes use paragraph proofs. Now, a paragraph proof is just another way to write it. We're usually going to use two-column proofs because two-column proofs are very easy to see the order and logic to them. They're very easy to read. But a paragraph proof is okay, but just notice that in each one they're still giving a statement and a reason. So each statement, each sentence here contains what they're doing next and why. So as long as we walk through that with a reason and a statement in each sentence, and we're still connecting the same logic, we can call that a paragraph proof. However, unless I specifically tell you that, I want you to use two-column proofs. And here is another theorem that we might use. This is the congruent supplement theorem. In this one, notice that saying angle 1 and 3 are supplementary, so they add up to 180 degrees. It's also saying angles 2 and 3 are supplementary, so they add up to 180 degrees. And since 3 is the same angle in both of those, we should be able to notice that angle 1 is going to be congruent to angle 2. Now, we'll have to prove that later. We have a similar thing with complementary angles, okay, where 1 and 2 are adding up to 90, 3 and 2 are also adding up to 90, so that I would know that angles 1 and 3 would have to be the same. We can also, this is a different one, we are saying that all right angles are congruent. Now the definition of a right angle is that that right angle is 90 degrees. So the measure of the angle is 90 degrees, then it's a right angle. So with these I would have to go through and say, okay, measure of angle 1 is 90 degrees, measure of angle 2 is 90 degrees, 90 is equal to 90, and then we could do some work and then say, therefore, they're congruent to each other. In this one, we're looking at two supplementary angles. It's telling us, first of all, they're supplementary, so the angles add up to 180 degrees. And it also tells us that they are congruent. So if they're congruent and add up to 180 degrees, after a few steps in a proof, we should be able to figure out that each one of those angles is 90 degrees. Therefore, by our definition of a right angle, being that 90-degree angle, we know that angle 1 and angle 2 are both right angles,